Before we proceed to the computation, let us analyze first the given situation. A teacher wants to determine the effectiveness of her teaching strategy. She gave a pre and post test where the lowest score that her students earned is 20 and the maximum score of 50. So there are 100 students that had been treated. Each of them generated scores after the treatment. Two groups of data had been presented. The first group are their scores for pre-test and the second group are their post-test scores. Our objective for this data is there a significant difference in the pre and post-test scores of the students? Our null hypothesis will be there is no significant difference in the pre and post-test scores of the students. And then the parameters, our significant level is set to 0.05 with the 95% confidence interval. And then we have the result. Result number 1 will be the p-value that had been calculated using the Kolmogorov-Smirnov test of normality for each of the group. So before we proceed to the computation for dependent samples, let us first test if they are normally distributed using the Kolmogorov-Smirnov test of normality. So our computed probability value for the first group, which is the pre-test, is 0.26897, which is greater than our significance level of 0.05. So it is normally distributed. So the next one is the second group, which is the post-test. The computed probability value is 0.11687, which is greater than 0.05, which means that our data is normally distributed. And so we have now the basic assumption that our samples are both normally distributed. Let us now see if there is a statistical difference in the pre and post-test scores of a student.
We have here treatment number 1 for pre-test and treatment number 2 for post-test. Let's copy the data sets and paste it. Our significance level is 0.05 and we will choose the two-tailed hypothesis. Then press the calculate button. And so we have now the result. The result says that the t-value is 11.782572. We have positive result, which means there is greater evidence that there is a significance difference, and then our p-value is 0.0001 and it is less than our significance level at 0.05. Therefore, our null hypothesis will be rejected. Result number 1. p-value is 0.0001, and for the interpretation, the null form of hypothesis will be rejected. There is a significance or significant difference in the pre and the post test scores of the students. Our data analysis is the given dataset had been treated with t-tests for dependent or paired samples, since each group will consist of the same participants or respondents. Each group had been tested with Kolmogorov-Smirnov test of normality with a result of computed p-values equivalent to 0.26897 and 0.11687 for pre and post-test scores, respectively. These values suggest that the dataset in each group were normally distributed since their computed p-value is greater than the significance level at 0.05. The computed value of t is 11.782572, and this indicates greater evidence that pre and post-test scores have a significant difference. On the other hand, treating the two datasets with t-tests for dependent or paired samples, it yields a p-value of 0.0001, which is less than the significance level of 0.05. This implies the rejection of the null hypothesis. Therefore, the pre and post-test scores obtained by the students have a significant difference. The results of the study show that there is a significant difference in the pre and post-test scores of the students. These conclusions indicates that the student obtained higher scores after than the beginning of the lecture, which means that the activity was successful in increasing participants' knowledge of the taught content. A study from Cache N.S. et al. 2017 found that the students' performance in post-test was better compared to pre-test. Malik and Alam 2019 discussed the importance of pre-test or and post-test design as an important assessment tools that help in direct and effective evaluation of a course or lecture to improve the student learning. The idea of pre-test and post-test evaluation model is to measure baseline knowledge of participants at the beginning of the course or lecture and compare it with the knowledge and gain after the course. These related studies support the implication of this study based on the analyzed data.